Okay, we need to have a conversation about materials. Bambu sells this stuff on their website. It used to be known as Support G, and now it's known as Support for PA/PET, which is nylon and PET. This is probably the most useless filament I've ever run across, and we are going to go over some of what makes it useless and some good alternatives. Okay, so let's go over some of the advertised features of this particular support material, since it's the catalyst for all this testing in the first place. On the website, it says easy removal by hand. Perfect support interface is what the website claims it is. It's perfect for PA6-CF, PA6-CF, PETG-CF, and PAG-CF, etc. This is all as advertised on the Bambu Labs website. It lists the cautions for use as only used for support interface, not to be used for printing models alone, and it says to dry it out before use. It also says to remove the support structure promptly. I'll get into that a little bit later. Basically, for the sake of this testing, I was not able to do that, obviously because I had to print all these samples. However, I did do some testing off camera with samples printed and then tried to remove the supports immediately. I found that it did not make a difference, and you'll see why in a second. It says it is AMS compatible, but it's not AMS Lite compatible. So you guys with the A1s and the A1 minis, sorry, you guys are left out. Realistically, you're only going to run this with the X1 carbon, or maybe the P1S if you have a hardened steel hot end on it. Partially because this is only really useful, or in theory, it's only really useful if you're printing like carbon infused nylons, which you'll want a hardened steel nozzle for anyway. So for this testing, obviously I'm not running it through an A1 or an A1 mini due to the AMS restriction. This will be going through my X1 carbon with the AMS combo. It was dried for 12 hours before we do this testing. It was in my Polymaker poly dryer. Unlike the other filaments we're going to be testing today, this one is only used as the interface material because it serves no purpose to print models out of it, and it's advertised that way on Bambu's website, as I just talked about. Some of the problems that I'll talk about in a second, some people seem to have found solutions for online, and it looks like a lot of their problems were solved by increasing the purge volume, either by a multiplier of 1.5 or 2. I tried both of those off camera, and it did not make a difference for me. It's possible that other people may have better luck running those multipliers. Although it's listed to support PET, I don't actually have any PET on hand, but I do have some PETG, which is not advertised for. We're gonna see what happens purely out of curiosity. I won't hold it against this support material if it doesn't work, solely because PETG is not listed as one of the advertised materials that it can support. Okay, that's all the info for the support filament. Let's take a look at some of the other samples that we have. Alright, these were printed in pairs, all except these last two. Each one has a base material and an interface material, and then the other partner pair for it is swapped. With the exception of these two, because these are the Bambu Labs support filament, and it's obviously only advertised as support material, so we're not going to be printing any models with it. Alright, so on our list we have Fiberon PA6-CF, which is kind of the standard carbon fiber nylon, with a Bambu Labs ASA support interface. Below that we have Bambu Labs ASA-CF, Fiberon PA6-CF as the support interface, then obviously swapped as well. Below that we have the Bambu Labs ASA with the PETG support interface. Below that we have Bambu Labs ASA-CF with the Overture PETG support interface. Below that we have the Overture PETG with Bambu Labs PLA-CF. Below that we have the Overture PETG with a Sunlu PLA interface, not the CF version. Below that we have the Fiberon PA6-CF with the Bambu Labs support interface. This is actually what it's designed to do. This is the perfect use case for it, in theory anyway, at least on paper. We'll put that to the test and you'll see why I sound skeptical. Below that we have the Overture PETG with the Bambu support interface. This is the one that I was talking about. I'm not sure how this is going to react, solely because the support material is not designed for use with PETG, only with PET. Okay, as far as print settings, we're using a 0.6mm nozzle because that is what Bambu Labs recommends for pretty much anything composite. And we have lots of CF infused materials in this test, so that's what we're running. I'm running a 0.18mm layer height. This is the smallest layer height that Bambu Labs has a preset for, because although my preset is heavily modified at this point, that is a good indication of where the diminishing returns are for a certain nozzle size. This is important. We're running a 0mm Z offset. Basically what that means is the support material doesn't have a gap between where it ends and the part begins. I'll get into that in a little bit. We're using a grid style support. I'm running normal supports, not tree ones, with manual painted on support enablers. We're using 3 interface layers for the support. This can possibly change things a little bit. The more layers you add, theoretically, the easier it is to remove the material because there's more mass in between the similar part types. Our default base pattern is rectilinear. That's what we're running. We are running a rectilinear grid interface pattern. I find that helps make the area where the support material meets the model, it smooths that out a little bit. It's a pretty good interface pattern that I would recommend for this. We are running a support object XY distance at 0.5mm. Basically, that is the distance horizontally from where the support ends and your part begins. It leaves a little gap here, and in a pinch, if you're having issues removing this, it can be easier to slot a screwdriver or something in there and get some leverage to pry on. The support object first layer gap is very similar to this, except we're running it a little bit smaller just for the first layer to try and increase the footprint of the support material. And we are running 100% infill on all of these because most of my models end up running 100% infill because I need them to be strong. Alright, so before we talk too much about this, we need to understand our 0mm Z offset. Basically what happens is you have your support material, and where it meets the part right here, you can space that gap a little bit. So basically you can make the support material start a little bit lower and end a little bit sooner, and that basically provides a gap in between the support material and the part, and sometimes that can help remove or help with the support material removal because the layers won't adhere as well. Generally, Orca Slicer is smart enough to differentiate, and the lines for the pattern will be perpendicular to each other. So the support material has vertical lines, the actual part material where that meets will have horizontal lines, and that is important so that you don't have lines that interlock like teeth. It can help with support material removal. One other thing to note on my testing, one of these separated so easily that it separated before I could even get it off the build plate. This is the Bambu Labs ASA with the carbon fiber nylon interface layer. I think part of that was due to the warpage that this part experienced. It may be hard to tell, but this thing is tacoed quite badly, and I think it just warped on the plate and ripped itself off of the support. But it is indicative that the support interface did not adhere very well to the part itself, which is what we want. And if you flip it over, you can see that the finish on the bottom side is very good. So if you can get past the warping, I think this was a pretty good test. Alright, obviously this one came apart on the build plate. but we can look at its partner, which stayed intact. And we can see how easy this is to remove. I'm just going to press with my fingers and see if it comes off that way. It doesn't, so we're going to grab some pliers. Alright, I've got some pliers on it now. We're just going to rip it off. That came off quite easily. I can flip it over, look at the part. That looks quite good. You can see there's a small ridge where the join was, where the support material ended. And that's part of that support object XY distance. I have that set a little bit higher just so we can get some space off of this so it doesn't accidentally adhere to the wall, and so you can get a tool in there and pry if need be. Alright, next up we have Bambu Labs ASA-CF with the PA6-CF interface layer. That one just came right off in my hands. No tools required. Let's take a look at the finish. We did get a little bit of layer separation there. Not sure. Yeah, that is part of the actual part itself. That might be indicative of bad layer adhesion in the part itself rather than the support material. But the finish is really nice, and there's very little ridge where we have our XY offset. Alright, next up we have its partner. This is the PA6-CF nylon with the ASA-CF interface. It did come off in my hands. There was a little bit of force required, but it wasn't bad. Looks like the support material did leave a string behind, but we can just pry that off and it's okay. You can see that the surface finish that it left is quite good. Alright, next up we have the Bambu Labs ASA with the Overture PETG interface layer. This one is a little stiff. I'm just going to help it along with some pliers. That one wasn't so good. It definitely took some force and it left some material behind. That was definitely suboptimal. It left some material behind that would probably take some finagling to get off or scraping out with a screwdriver. Definitely not toolless. Next up we have its twin, the Overture PETG with the ASA interface layer. This one isn't able to be done by hand either. I'm gonna whack some pliers on it. That one came off a lot easier, but it does look like it took a layer of the PETG with the support material, which is definitely suboptimal. Alright, next up we have the Bambu ASA-CF with the Overture PETG interface. It's basically the same thing, just ASA is infused with carbon fiber. I definitely wouldn't recommend this one. It left a layer behind the support material. The bond is definitely stronger with carbon fiber. Not great. Then we have its partner. This is the PETG with the Bambu ASA-CF interface. This one was definitely a little bit messier to get apart, as you can see, but the finish is pretty good. I'd call that passable. Alright, now we have the Overture PETG with the Bambu PLA-CF interface. That one actually came apart really well. It did try and take one of the perimeter layers with it, but all in all, if you can live with the perimeter layer sacrifice, that's pretty good. The surface finish is okay, there's definitely some blemishes in there. Could be worse considering this is a carbon fiber infused interface layer. They tend to stick a lot better, for better or worse. Also, it is worth noting that whatever blemish imprinted itself on the part actually came from the interface layer. My guess is that there was an error when it was bridging in between the supports, because the density is a lot lower in the supports. Alright, now we have its partner, Bambu Labs PLA-CF with the Overture PETG interface layer. That one came apart really well. It did leave one strand behind, but nothing you probably couldn't pick apart with a pair of pliers or something. Alright, the last pair for the twin filaments. This is Overture PETG with the regular Sunlu PLA interface layer. This is not carbon fiber infused PLA like the previous one. That one came apart really easy. It did seem to try and take away the external wall, but that's not the end of the world. It seems like a fairly common problem. Alright, this is the regular Sunlu PLA with the PETG interface. That one was real easy too. It did leave some PETG behind as well, but that's kind of neither here nor there at this point. Alright, this one I don't know what to expect for. This is the Overture PETG with the Bambu Labs support material for the interface. We'll see what happens here. Like I said, this support material is not designed to go with PETG, only PET, so we'll see what happens. That actually came apart quite easily, but you can tell it left a lot behind and the surface finish is pretty bad. Last but not least, we have the Fibron PA6-CF, which is the carbon fiber infused nylon, and the Bambu Labs support interface. This is what this interface is designed for. This is also what I've been having problems with, as I'll show you in a second. It's stuck on there pretty good. I definitely can't get it by hand. That was pretty difficult even with pliers. It looks like the part took a lot of the interface layer with it, which is obviously suboptimal. This is stuck on there pretty good. I'm having a hard time pulling that off. That's going to be a pain to clean up. And that's what this filament is designed for. And this is the problem that I've been having. I'll show you in a second on a real part. But this filament is basically worthless. ASA seems to do a much better job releasing, and obviously the surface finish on the ASA stuff is a lot better. For comparison, the one on the left is the dedicated Bambu Labs support material for PA and PET, and on the right is just simple ASA. Basically, to me, it seems like there is absolutely no reason to run the dedicated Bambu Labs support material when ASA seems to do a much better job and it's far cheaper. Bambu Labs support material is about $40 for half a kilogram. The ASA is about $40 for an entire kilogram. So it's about double the price for worse performance. Alright, these are functional parts printed in the PA6 with the Bambu Lab support material. You can see where the support material was, kind of along here. It was very difficult to remove. One of these was printed with a multiplier for the flush volume of 2. I think it was this one. And this one was printed with the regular multiplier of 1. That works out to be about 420 millimeters cubed for the standard multiplier, and 840 for the multiplier of 2. And as you can see, it did not make much of a difference. But that seemed to help other people on Reddit, so I don't know, maybe give it a shot. Alright, there you go. Those are my print settings and all of the materials that I had on hand to test for Interface. Obviously some of them worked better than others. I would highly recommend steering clear of the Bambu Labs support material though. It is expensive and it just doesn't work. In fact, it works worse than a lot of other filaments that you will probably have on hand for projects anyway. If you're printing PA6-CF or any carbon fiber infused nylon for that matter, I would highly recommend ASA. It seems to separate pretty well and leave a fantastic surface finish. If this has been informative at all, I might do a tier list and rank each one of the combinations on how easy they were to remove. So hopefully people will have something to reference in the future, because as I said at the beginning of the video, there seems to be a lack of information regarding this sort of thing.